Okay, so here we are with multiplying, dividing rational numbers. Alright, so multiplying rational numbers, when you multiply, you go straight through and you do exactly that, just multiply. Multiply the numerator and multiply the denominator, okay? Let me just see here. Alrighty, so we're going to multiply numerator and denominator straight through, okay? You try to do your reducing, you can either do it before or after, but you need to reduce just like we've always done before with rational numbers, okay? So reducing is always part of it. Alright, so get back into my pencil here and we'll start. Okay, so 5 times 2 is the first thing we need to do here. Okay, so we're going to take a look at 5 times 2 first. There we go. Let me just get myself set up here. Let's change that pencil. Okay, so 5 times 2, and that'll give us 10. Okay, and then 6 times 7, which also gives us 42. Okay, and like always, you need to reduce. So you take a look at this, and the greatest common factor between these two values is just 2. And that would give us a 5 over 21. Okay, and that would be our final answer for that one. Alright, you could have reduced beforehand if you wanted to, and what that would look like is you could have done 5 over 6 times 2 over 7, and you can look vertically this way to see if things reduce, if a 5 and a 6 reduce in any way. In this case they don't. You could have gone this way to check if the 2 and the 7 reduce, but they don't either. What you could do though is also go across to see, and you can see, like we reduced the 2 out of the final answer here, we can simplify here. This will become a 1 and we can divide this out, because 2 over 6 is really just 1/3, and you still get the same answer. It doesn't matter to me which way you do it, but you need to reduce at some point, okay? Always reduce rationals as low as you can, okay? So -3/7 times -4. Oh no, where's the denominator on -4? There is a denominator on -4. We've talked about it, and it's always a 1. Okay? So if it helps you to put that in there so you can see it, do that, okay? Remember where this negative sign, we're going to take it up into the 3. So I'm just going to rewrite it first. Alright, and then there's brackets all around that, and we'll keep the brackets around this. And now we can see numerator, denominators, where they are, what the values are for each of them, and now we can go ahead and multiply through. -3 times -4, that'll give us a positive 12, and then 7 times 1 gives us the 7. Okay? Denominator, numerator, and again, you can leave it as an improper, okay? That doesn't matter, or you can change it to a mixed if you like, okay? Whichever way you want to do it is fine with me. So here's -3 over -4 times 2 over -5. Remember, -3 over -4 is really just 3 over 4. Good job, guys. So 3 over 4, it is just a positive. And remember what we do with these negative signs when they're down here. We're going to bring them up here, and we're going to get -2 over 5. Okay? And now we can just multiply straight through again. You can check to see if, I'll do this one where we reduce it before we actually do the multiplying. And I can see that 2, okay, so see what I can do here with this. So 2 and 4 will reduce down, and they reduce down to 1 and 2, because 2 over 4 is the same as just 1/2. Okay, so you can do the reducing first or after, but you need to do it. -3 over 10, that's our answer for that one. Okay? With our mixed numbers, we need to change them to improper before we multiply. Okay, we can't do it any other way. Here you have to, and that's why I did the same thing with adding and subtracting. Okay, so just get into the habit of changing it. I think you'll have less errors there. Remember with these, bring the negative down first, then do your conversion. So 4 times 2 is 8 plus 1 gives us negative 9 over 4. Okay, and you could put that negative sign where it should go right away, right up here. Okay, times 5 over 3. You check to see if you can reduce. Okay, if you can, you're looking at being... Okay, so like I said, you can reduce either before or after. I'm going to do it again before. And I look at the 9, and just like before, I'm going to highlight these for you. So I'm going to look at the 9 and the 3 in this case. And 9 over 3 is really just 3 over 1. Okay, so we can reduce that down like we reduced fractions before, and you'll end up with a negative 3 here, and you'll end up with a 1 here. Okay, now that means that we do negative 3 times 5, so now we'll get negative 15, okay, over 4. Or what you could have done, if you liked, you could have left it without the multiplication, without canceling there, and we can reduce it afterwards. So in this case you would get negative 9 times 5, which is negative 45, and over 12. But again, what can we reduce out of both? We can divide out of 3, just like we divided out of 3 before. So this can be divided by 3, and this can be divided by 3. And we still get negative 15 over 4. Okay? And then this example here, again with those negatives, put them in the numerator, and you put them in the numerator and you see what happens with the signs. Automatically you should know from this question what sign will the answer have, will the product have. Right, it'll be positive. Good job. So with that, we'll go through it and we'll see negative, we'll bring the negative down. 3 times 1 is 3 plus 2 gives me the 5 over 3. And I've already put it in the numerator. Then we'll keep the brackets around us so we see the multiplication there. Negative 4 times 2 is 8 plus 3 is the 11 and over 4. And when you look at this one, there's nowhere where I can cancel. I'm looking across on the diagonals. 3 and 11 doesn't reduce, 5 and 4 doesn't reduce, 5 and 3, 11 and 4, I can't reduce anywhere. Okay, now we look at negative 5 times negative 11 gives me positive 55, and in the denominator 3 times 4 we get 12. And if you can't reduce before, you're not going to be able to reduce after you multiply. Okay, so then you know that that's going to be as far as you can go with reducing. Okay, so that's multiplying. Whether you reduce before or after is up to you, but you need to reduce at some point. Remember, numerator times numerator and denominator times denominator. And then all the integer ideas that we had from before about multiplying and dividing, a positive and a positive, negative and negative give you positives, positive, negative, negative, positive gives you negatives. Okay? So dividing. First we're going to talk about reciprocals, and then we'll do some dividing. Okay, so make sure you understand what a reciprocal is, and that is when you have 2 over 3, the reciprocal of 2 over 3, the reciprocal of 2 over 3 is 3 over 2. All I'm doing is flipping the numbers around. Okay, so you take the numerator and it becomes the denominator, denominator becomes numerator, and you flip them around. And the thing about that is, one of the properties of that, if you take a look at the ones we've done up here, if I take a look at 2/3 times 3 over 2, we always get 6 over 6, or 1. We always get 1, no matter which ones you do here. Negative 5 over 7 times 7 over negative 5, okay, still gives you negative 35 over negative 35, which always equals 1. Okay, so the reciprocals always do that. The one that's important and you should get through your head, and like I've mentioned before over and over again about integer values, that they're always over 1, that idea of the invisible ones. 5 has a reciprocal, Okay, the reciprocal is, right, and I think you got it from the other one there, 1 over 5. And now, like above, -2, the reciprocal is, and it's still okay, negative, or 1 over -2 is the same as -1 over 2. So even when you do the reciprocals, take that negative sign, put it in the numerator, okay? Alright, so that's it for multiplying. We just started talking about reciprocals, and now we'll go on to dividing, and that'll be in the next lesson.